Right, a past examination paper question. So this was an A-level core mathematics C1 past paper question from the year June 2009, and this was question 8 of that paper. So let's have a look. The points A and B have coordinates 6, 7 and 8, 2 respectively, and the line L passes through the point A and is perpendicular to the line AB as shown in figure 1. And in part A, find an equation for L in the form ax plus by plus c equals 0, where a, b and c are integers. So let's have a look at the most important parts of this question. So in this case, this line L passes through the point A, okay, and we know that the coordinate of A is 6, 7, as illustrated on the diagram, as illustrated on figure 1, but it's also perpendicular to the line AB. So remember this part of the sentence. So in coordinate geometry, if two lines are perpendicular, the product of their gradients equates to -1. So we know that m1 times m2 is equal to -1 for when two lines are perpendicular to one another. So with that being said, let me first work out the gradient of this line AB so that I can work out the gradient of the line L. So if I revert to blue, so let me start over here, say, so here's part A. So we know the coordinates of A. So from the question, the coordinate of A is 6 and 7. Let me name this x1 and y1. And we know the coordinates of B from the problem, it's 8 and 2. So let me name that x2 and y2. So using the coordinates of A and B, let's work out the gradient of AB. So first of all, gradient of AB. Let me name that gradient m1, say. So m1's equal to. So if we have 2 points, to work out the gradient, the formula is y2 minus y1 divided by x2 minus x1. So I've named my points. So let's substitute the data in. So y2, that corresponds to 2, minus y1, y1 is 7, divided by, and x2 is 8 rather, minus x1 being 6. So if I continue along the line, 2 minus 7 is -5. So -5 on the top, divided by 8 minus 6 is 2 on the bottom. Let me leave it as 5 over 2. So 5 over 2 being the gradient of AB. That is the gradient of this line on the figure AB. Okay, so I've named that gradient M1. So M1 is the gradient of AB, and we can use M1, we can use this condition over here for when two lines are perpendicular to work out M2, and M2 for me is the gradient of L. So let's use M1, let's use this condition to work out M2, the gradient of our line L. So back to blue pen. So in this case, I'm going to say gradient of the line L. So I'm naming that M2. So we're using the condition that M1 times M2 is equal to -1. And M1, the gradient of AB, that is -5 over 2. And if I rearrange this formula for M2, M2 then is -1 over M1. And if I substitute M1 in, the result for M1, so for M1 we had -5 over 2, so it's -1 over -5 over 2, which is 2 over 5. So 2 over 5 being the gradient of L. Okay, so if we go back to the question, so the question did say that the line L passes through A has coordinates 6, 7 and is perpendicular to AB, and we need to work out as far as A is concerned the equation for L, but specifically in the form ax plus by plus c equals 0. A, B and C are integers. So let's work out the equation of L. So it passes through the point A. So let me continue over here. So the equation of L, and I'm going to be using this formula, y minus y1, that is m multiplied by x minus x1. So x1 and y1 in this formula are the coordinates of the point where the line passes through. So x1 and y1, and the coordinates of the point that this line passes through is this point A. According to the question, A has coordinates 6, 7. So let's make a note of that, 6, 7 for x1, y1. As far as m's concerned, with regards to this formula, m is the gradient of L, and m is m2 in this case, and m2 2 over 5. So with that being said, let me substitute this data into the formula. So y minus y1, 7, that is equal to m 2 over 5, open a bracket, x minus x1 replaced by 6. And if I get rid of the brackets on the left hand side, I have y minus 7, that is equal to 2 over 5 times x is 2 over 5x. 2 over 5 times minus 6 is minus 12 over 5. Now let me get rid of these 5's in the denominator. So in order to do that, I can multiply the entire equation by 5. So 5 times y is 5y. 5 times minus 7, minus 35. 5 times 2 over 5 is 2, so 2x, minus 5 times 12 over 5 is 12. Okay. Now, going back to the question, we do need to write it in the form ax plus by plus c equals 0. A, B and C are integers. So what I'm going to do is I'm going to take all of my terms. It doesn't matter at this stage. I'm going to take all of my terms to the left hand side. So if I take these two terms from right to left, my answer is going to become 2x to the left is minus 2x plus 5y, and minus 35 plus 12, so minus 35 plus 12 is minus 23, and that is equal to 0. So this should be the answer to part A. Right, next part. So given that L intersects the y-axis at the point C, find the coordinates of C. So L intersects the y-axis at the point C. So if we refer to the diagram, so remember, when the line crosses or intersects the y-axis, the x coordinate is 0. So x is 0 at this point C. So let's use this in order to work out the coordinates of C. So let me continue up here. So first of all, let me copy down the answer for L. So the equation of L we worked out. So we worked out as minus 2x plus 5y minus 23 equals 0. So let me copy down that equation. So we need that for certain. So here is the equation of L, of our line L. And remember the idea. So when the line L crosses or intersects the y-axis, x is equal to 0. So let's replace x by 0 in this equation for L. So we'll have minus 2, x replaced by 0, plus the 5, y, minus the 23, and that is equal to 0. So if we get rid of the brackets, so minus 2 times 0 is 0, so 5y minus 23 is equal to 0. Taking the minus 23 to the right, so 5y is plus 23, so y therefore will be 23 divided by 5. So that is the y coordinate of C. So therefore the coordinates of C will be the x coordinate is 0 and the corresponding y 23 over 5. So that should be the solution to part B of this problem. Right, now for the last part, part C. Find the area of the triangle OCB where O is the origin. So let's have a look at the diagram. So we need the area of the triangle OCB, so this triangle over here, with reference to figure 1. And remember the formula for the area of the triangle, it's half the base times height, or base times height divided by 2. So what we need to do is, with reference to this diagram, we need, and let's regard OC as being the base. So we need the base dimension, so we need the length of OC, and we also need the height of this triangle. So the height will be the perpendicular height, so this height over here. Now if we think about it, we do have the base length, or the length of OC, because we have the coordinates of C, the coordinates of C being 0, 23 over 5. So CS coordinates 0 and 23 over 5. So we know the coordinates of C, 0, 23 over 5. So the y coordinate would give us the base length of the triangle, or the length of OC being 23 over 5. And the perpendicular, as for the perpendicular height, the x coordinate of B being 8, that will give us the perpendicular height, or the height of the triangle. So we know the base length 23 over 5, we know the height of the triangle 8. We can use these to work out the area of this triangle OCB. So let's have a look. Let's have a look at this part C. Let me try part C here. So the area of triangle OCB, so it's going to be half, and it's half of the base length. So the base, let me take that as OC, multiplied by the perpendicular height. So let me name this point on a diagram X, say. So you can name it any letter you like, so I'm calling it X. So multiplied by BX, where B is the vertex of this triangle. So if I substitute the data, it's going to be half of, and OC, we've noted that from our diagram, OC is 23 over 5. So 23 over 5 multiplied by BX, the height, 8. So I can make a cancellation here. 2 goes into 8 4 times. And if I do this calculation, 23 times 4, 92. So 92 over 5. So it's 92 over 5. That being the area of the triangle OCB. And then we're done. So part C complete. So not only that completes part C, so we completed this question in its entirety. So I hope you enjoyed this video. I hope you liked the video. If you did enjoy the video, be sure to like and subscribe, and I hope to see you again. Thank you.